Alright, these are the quiz corrections for Chapter 4, Quiz 21 on April 16th, 2015. For problems number 1 and 2, it says write a congruent statement for each pair of triangles. And then number 2, give a justification with a theorem or postulate why they are congruent. So the congruent statement for number 1, I started with the letter L, which means you have to start on L. So I decided to go in this order, L, P, A. That means you have to go in this order. 1, 1, 2. Then that would be 1, 1, 2. So Y, A, P. Also take a look at if you chose L, A, P. I'll take a look after class if you did something different. With these congruent marks, I can do angle, side, angle, so something like this, angle, side, angle, or I can also do side, angle, side, the reflexive, or you could have done something like angle, angle, side. So any of these three, if you had one of them, got it correct. Those were 2 points each. Question number 2, the missing there is reflexive. Reflexive sides, which means they share a side, so I draw 3 hash marks, therefore it's side, 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 is your postulate or theorem. I gave you the first letter N. Again, if you did something like N-E-O, I'm willing to change it. N-O-E, so 2, then goes through 3. That would have to be S-O-E, going through 2, then 3. Question number 3, write which postulate, if any, could you use to prove the 2 triangles congruent? If not enough information is given, write not possible. So the marks are here. The missing there is reflexive, so I have S, A, S. Number 2, you have the box there. You have congruent sides, and then you have reflexive. So you have something like this. Side, side, angle. Now if you wrote side, side, angle, I would subtract 1 because side, side, angle with a right triangle is called HL, hypotenuse length. Question number 3, you have a right angle, but you only have an angle and then a side. 2 of those congruent does not make us prove that 2 triangles are congruent. Question number 6. Marks are kind of light, so I'll just darken those. That would be side, side, side. Side, side, side congruence. Question number 7. This is like a bow tie. Therefore, you have vertical angles as you're missing. So those missing information is kind of like extra clues you need to write on your picture. That's what the missings are for. So that would be angle, side, angle. Question number 8, I have 2 arcs, 1 arc, and then a side, so that would be angle. Oh, are those marks on there? Thumbs up, thumbs down? Just like mine? Oh, I have to regrade it. Angle, angle, side. So if you had angle, angle, side, I'll change your grade later. Don't be shady and change it now. Question number 9. I have these 2 congruent arcs, so that tells me the 2 angles are congruent, and then this one here. So assuming that the triangles are congruent, then if you rotated this triangle around, this is another way of doing the problem, right? Rotating around, so you have the 2, and then 1 over here, then the angle left over is 108. 3x equals 108. The common mistake was trying to use triangle sum theorem. 3x equals 108, therefore x equals 36. That question was 4 points. Question number 10, 4 points. Find the value of each variable. I started here. That's a linear pair postulate, so 125 plus x equals 180. You'll solve for x to be 55. Notice how I have my congruent sides here. You can circle those. The congruent sides point to the congruent angles. Therefore, x and z are my congruent angles. That's called base angles theorem. So x and z are the same, therefore z is 55 degrees. Now that I know this is 55 and this is 55, then I can use triangle sum theorem. X plus z plus y equals 180.
Hey, I need to see Taylor to see over.
Question number 11. Be careful and read the directions. Now, this is kind of small, you can see on your paper. The measures of two of the sides of an equilateral triangle, so draw one, are 3x plus 15 and 7x minus 5. What is the measure of the third side in the inches? So number one, if you just drew an equilateral triangle and labeled it, such as 3x plus 15 and 7x minus 5, I gave you 2 points out of 4. Here's the common mistake for students. They automatically think that they see a triangle, then they try to use triangle sum theorem. Blank plus blank plus blank equals 180. But triangle sum theorem only works for angles. Angle measures. Those are inside the triangle. This one says the measures of the two sides. If they're the sides, we write them outside. These congruent marks tell us that each of the sides are equal to each other. 3x plus 15 equals 7x minus 5. You'll solve for x equals 5. Now a lot of students will try to stop there. But it doesn't say solve for the x. It says what is the measure of the third side? Well, you take x and substitute it into one of the sides, and you'll notice that they should all be the same, right? 30, 30, 30. That's what an equilateral triangle is. The answer is 30. That side was at 32 points. So I add up all the points, and then I add that score to the corner. I add them up to the corner. Question number 12 on the back side. One method that cannot be used to prove two triangles congruent, that would be side-side angle. Question number 13, in the accompanying diagram, EC is congruent to FA. EC is congruent to FA. Then it says EC is parallel to FA. EC is parallel, I know that by my arrowheads. Triangle EGC can be proved congruent to triangle FGA by what? So automatically I know with parallel lines, they're talking about angles. The missing in that one is, or the hidden is alternate interior angles. Parallel line to the transversal. Parallel line to the transversal. I also have another missing. There's vertical angles, and I have that side, so I can do angle, angle, side. Question number 14. The diagram BA is congruent to DA, so mark up on your picture. AB, so here's AB, and CB are perpendicular. Perpendicular lines form right angles, and then it says AD is perpendicular to CD. Because they're both right angles, they're 90 degrees, therefore they're congruent angles. My missing in this one is reflexive. In this problem, I can do side, angle. Now, side angle is not a way of proving two triangles congruent, but if it's a right triangle, which we do, then I can use HL. Remember, HL is SSA with the right triangle. Question number 15. In triangle ABC, so draw a triangle, it's a little bit small and messed up. AB and AC are congruent. Let me draw that again. Doesn't matter how you label your triangle, what's most important is the given information. So AB is congruent to AC. The measure of angle B is 40 degrees, so put 40 up here. What is the measure of angle A? Well, again, the congruent sides are pointing to the congruent angles. So C is 40. Now I have two angles of a triangle. Now I can use triangle sum theorem. That math's incorrect. So you would get 40 plus x equals 180. You get 80 plus x, or x is my angle A, to be 180. Therefore, x is equal to 100. That would be choice 4. Question number 16, solve for the missing variables. I have A, B, and this was 54 degrees. There again, you have your congruent sides. Base angles theorem, they are pointing to congruent sides. Therefore, these two are congruent. Therefore, A is 54 degrees. Once I know that's 54 degrees, then I can use triangle sum theorem. 54 plus angle B equals 180, and you'll solve for B to be 72. Now, in this problem, you can also use linear pair. That's how you get to the second triangle. You can't start on the right triangle. This triangle over here on the right has two unknowns, actually three unknowns, so you can't start there. I use a linear pair. 54 plus C equals 180. You get C to be 126. This one here is 126. That's the vertex of my isosceles triangle. Isosceles triangle has two congruent sides. Same idea. Base angles are congruent, therefore D and E are the same. So my equation was 126 plus E plus D equals 180. I just said D and E are the same. There's my substitution. So I have 126 plus 2E equals 180. Subtract 126 from both sides. 2E equals 54. Therefore, E equals 27. Here's the chart I used to help you understand how I graded that problem out of 4 points. If you got them all correct or you missed one problem, it gave you 4 points. If you got 3 correct and 2 wrong, it gave you 3 points, and so on. Question number 17, don't feel bad for you because this was the same exact question from last week's quiz, which many of you guys missed and missed again. Classify the triangles based on their side lengths. So it doesn't have it on there, but it might be helpful for me. I know that one means one blank is meant just for side lengths. The other one's about angle measures. So you have 30 and 89. You can use triangle sum theorem to get 61. All of my angles are less than 90, therefore it's an acute triangle. None of the angles are the same, therefore none of the sides are the same. You have a scalene triangle. This next one over here, you have a right triangle. That's the angle measure. The sides show you different hash marks, therefore none of the sides are the same. That's called scalene. This one over here, you have two hash marks so that they're the same, therefore it's two sides are congruent. That's called an isosceles triangle. And you have this angle here, which is more than 180, therefore it's an obtuse isosceles triangle. And the last question, you have all of the sides are congruent. That's called equilateral. Equilateral is also equiangular. Those are your two answers. Each of these questions were worth 1 point each. And the last question, the proof in the top right. LN bisects two angles, OLM. So OLM, you're cutting it in half. There's my two congruent angles. And LN bisects angle ONM. ONM. This angle is cut in half. There's the knife. There's my two congruent angles there. There I have angle, side angle. So segment LN bisects angle OLM and ONM. That's given information. Number 2, then I'm just these marks here. Angle OLN and MLN are congruent by definition of angle bisector. I also have this one down here. LNO or ONL is equal to LNM. I have my two arcs there. Definition of an angle bisector. I have my reflexive here. LN is equal to LN, reflexive property. The two triangles are congruent by angle, side, angle.